Hey everybody, hope you're well. Today something slightly different. This is going to be a video on me making and putting together a Bwack Saver. Now, what is a Bwack Saver? Bwack is a guy that's a lot more technically savvy than me, and what he's very kindly done is released as open source a board and instructions on how to make a saver for the Commodore 64, and the idea is that it cuts the 5-volt rail if it goes above a certain limit to protect all the chips, because the Commodore 64 power supply was notorious for the 5-volt rail failing, shorting out, putting out much higher voltage into the chips. So Ray Carlsen came up with a saver, which I did do a video on knocking some of those up out of scraps that I found on old boards, and do work. But a lot of people said in that comments that, why don't you look into a Bwack Saver? Now I did, but at the time it was a different version of this. It was a lot harder to make. He's come out with this new version which is all through-hole components. You see it says there, C64 Saver Rev 2.4 Bwack 2018. So thank you Bwack for releasing that. But let's get this together, test it, and then put it in a C64. These could have applications for not just the 9-volt. If you look at how they're laid out, then the 9-volt rail basically just goes straight across. So it doesn't have to be 9 volts, it could be 12 volts on a 1541 2 power supply. It could be anything where you've got a 5-volt rail that needs looking after and another rail, be it 9 volts, be it 12 volts, be it whatever. So that's very nice. First thing I'm going to do is put a surface mount on with some hot air, because I want to do that first before all these other components get in the way, and then we'll start populating the rest of this board. Okay, so first things first, proper amount of flux. I'm going to turn on the hot air. I normally take it up to about, I don't know, 360 or something like that. I'm just heating up the iron, and I'm going to tin these pads. These are the MOSFETs. And yeah, just going to tin the pads a little bit with some leaded solder, and then I'm going to use hot air to, get it onto that ground plane. Tin these up. Let's warm the whole board up so I don't start heating one part of the board more than the others. You see that? It kind of jumped into place. Then I moved it again. Well, I think that's on there pretty well now. Flow onto there. Flow onto there. Okay, so I should have done a bit more homework. It looks like I'm working off a bill of materials which is for version 2.3. Well, I printed a board which is for version 2.4. I went on the Github and there is a schematic for the Rev 2.4. There were some changes. So we can now work out what goes where. Sod's law, that capacitor has changed. It's probably the only thing that has. It's now 47 mic. It's even labelled here, everything that corresponds. So I've got values for R1, R3, R5, all of them. Q1 is the 2N7000, Q2 is the MOSFET, TL431. I'll link all the GitHub stuff in the schematic. It's very, very well laid out and very, very comprehensive. Now the resistor spacing for the legs is a little bit short, so what I'm doing is that it's reduced the footprint of the resistor. Put the resistors in. Could have been a better job here where I started, but I figured they're not too bad. That's okay. I really like these boards. I'm going to think I'll buy some more stuff from PCBWay. I think really nice finish, really nice laid out by Bwack. So a quick sanity check. I like to just make sure I'm getting things in the right way. So this is the 431. I'll draw it out like that with a simple little pin out. So here it is on the drawing on the schematic. So the cathode of that 431 should go to R7. So let's just make sure we're putting in things the right way around, because it's not unheard of for the silk screen to be the wrong way around. So that would be the cathode there, and R7 will be there, so that's fine. I can put that in. This is S431Z, it's a knockoff basically. Like I say, you can get these out of a power supply, you don't have to go buying them, they're in pretty much anything, any kind of switch mode power supply where it needs a voltage reference. There we go. Straight through. So TL431 or S431Z is in there. 1, 2, Looks like it might be bridged in now. I'll check it in a sec. 3. Yeah, it is indeed bridged. Let's take that off. So we've got a serious bridge there, but it's no big deal. See that? They're now separated. Definitely not bridged. Likewise for our 2N7000, the gate is the middle pin. You can see here the gate is the middle pin, and that goes to the cathode of D2. So without hitting the, oh I did hit it, the cable that's becoming really quite annoying. Cathode of D2, sorry, the gate in the middle, cathode of D2. Can't see that, can you? Job, gate D2, cathode, so that's done. Yeah, I just realised that was a bit of a stupid example because it was the middle pin and it could have been backwards. So pin 1, which is presumably, come on you shit. Pin 1, which is presumably this pin, pin 1 should go to the anode of D2. So if that was the right way round, pin 1 would be there, and that would go to the anode of D2, which it does. So that is correct. I'll get that in there. That's a really nice design. I've just got to swap this cap because apparently the cap's 47k and not 47 mic. So we're almost there. Just one more piece of the jigsaw. I've got to add 2 jumpers. Jumper 2 here, the camera will ever focus, and jumper 4 here. The 9-volt rail goes all the way through. In standalone mode, he says that you've got to bridge this. And then on the 5-volt rail, he's helpfully written here in, so we know that's the unsafe 5 volts. And this is out, the safe 5 volts. So if we look on the schematic, bearing in mind this is pin 1, 2, 3. Pin 2 goes to the safe one. So this is pin 2 here, the middle one. And it's also, on MOSFETs like this, it's the middle pin is normally tied to the shield there. So we can tell that that is the safe rail. So it's got to send whatever it's whenever it closes, it's sending it onto the safe rail. So what's it taking in? Well, it's taking in 3, so that'd be 1, 2, 3, and 3 here. 3 here goes onto this rail here, and then it breaks. See on the schematic that 3 just goes all the way to the unknown 5-volt rail. So again, what we've got to do is we've got to bridge this between here and here, so that it can take in the dirty 5-volt rail and then pass it through if it's safe. And there's the finished product. I'm just going to check I haven't made any complete howlers, but you can see I've got the jumper there, the jumper there, so that those rails are now linked. It's a nice looking little board, nice compact, easy to put together. Just got red for input, white for output, so I don't get confused and completely screw it. Let's go plug it in. So I'm just calibrating everything. That says 5 volts, that says 5 volts. So we've got a baseline there, that's correct. So 4.89, 4.8 stroke 9. So let's take it up to 5. So we're at 5. I'll try and bring these close together without shorting something out. So 4.95. 5.1, let's that through, 5.2, no, it's gone. 5.4 it went, so it's doing its job. Let's just take it back. That's the TV coming on. 5.15, 5.2, 5.3, let's through. 5.3, let's through. 5.32, let's through. 5.34, let's through. 5.4 kills it. So that looks like a success. This machine was the one that had the Moody CPU. I'll link the video up here somewhere, which I chased my tail for days on and ended up basically socketing absolutely everything. This hasn't got a saver in, so let's put one in. This particular board is the 250407 revision, and in order to fit the saver I've got to cut this trace here which is where the 5V comes in and goes to the switch, and then I'm going to run it through the saver. So I'm going to make a very neat and repairable cut there, so that whatever power supply it comes across, it is defended. Poor little C64, I've cut the trace, it's no longer worky without the saver. It is easily repaired. All together, all sorted. It's on there with drone tape, it's packed up with, I'll show you the tape actually. It's this stuff, get it from Halfords. It's holding the trim on my car on after 3 years. There is no way that it's coming off, moving, doing anything. I did debate covering it in heat shrink, which I did, and then I thought no, might be temperature, not beneficial temperature wise, so I've left it open. So red is power in. Let's go into that connector on the power in connector. White is power out, or good, clean power. That's going back onto the switch. Third one back. Ground. Just scratched off a tiny little bit there and gone onto the ground plane. No harm done. Let's plug it in and see if it works. Did. On. No explosions, no exploding capacitors, and we're good. So that's Bwack's Saver 2.4. Thank you very much, Bwack. That is an awesome bit of kit. Thank you very much for releasing that, open sourcing it. I will link the GitHub in the description somewhere, either in the description or up here. And like I say, that could be used on disk drives, it could be used on other machines. Very, very nice compact design. And also PCB awesome job, very, very nice board there. I will be using them again. So thanks for watching, hope you enjoyed that. See you all later. Cheers, bye.